Hi, I'm Dave from Vivax Metrotech. Another video on how to get great locates done using the vLoc 3. We're going to focus on power applications today, power locating. We're going to do a couple of things. We're going to show the difference between clipping onto a power meter, a meter base for a power service, and clamping around the power stack itself. We're going to talk about locating secondary lines, the best way to locate secondary lines. We'll talk about locating primary a little bit. We're going to show you some effects of distortion when fields become distorted because of the presence of other nearby fields, caused typically by return path conductors. We're going to talk about the differences of where to put a ground stake and how putting a ground stake in a certain place increases or decreases the amount of distortion you face, among other things. So we're going to start with clipping onto a meter base. So here's our meter base, and we have a choice for putting signal on. We can either clip to the meter base or we can clamp around the stack feeding the meter itself. We're going to choose to clip to the meter base this time just to illustrate a few points on distortion. Now, my ground stake is way back there. I did that because I happen to know, because of the presence of this gas meter, that there's a gas line coming in here. And what I don't want to do is have any distortion, or I want to minimize the distortion on my feed, on my power feed, because of the presence of this gas line. So I'm chosen to put my ground stake way back there. And when I put the ground stake back there, we will pick up the gas service in a few minutes. I'll show you this. And we'll have about a milliamp, 1.5 milliamps of current on that gas service. If I put the ground stake right here in the ground, as I first did when I first got here, we end up with 4 milliamps. So we have more than twice the current on the gas service because we put the return point, the ground stake, too close to that gas trace wire itself. That underscores the importance of getting the ground return point away from other nearby utilities. Because we don't want to light up the gas, we want to locate and light up the power. So we've clipped on. We're using 8 kilohertz in our transmitter. We got 25 milliamps of current. Yep, 25 milliamps output of current. That's lots and lots of signal, more than we need. We're only going to locate about 150 feet down to the transformer that feeds this building. So we'll turn on the receiver. We're broadcasting at 8 kilohertz. Yep, so we'll tune in 8 kilohertz on the receiver. Here we are. Typically, when you begin this work, you want to get away from the leads themselves, so we step back 15 or 20 feet. I know the line's got to move out in this direction somewhere. The transformer's in that direction. So I'm going to step out to here, about 15 or 20 feet away, point my receiver at my connection point, and then walk in a big semicircle around my connection point. When you're doing this initial sweep, you don't swing the receiver. You don't swing it back and forth, you hold it still. So I point the receiver at my connection point, I just walk in a circle like this. And I continue to keep the head pointing. There's some signal, and there it is gone. So I have lots of signal there. Let's continue on. And I have a little bit of signal here. On this one I can see it, but I can't hear it because there's not enough signal. Let's go back to where we have the greatest amount of signal. So now we're ready to do our locate. We've picked up some signal here. We don't know if it's our signal or something else. So let's do a quick check. I'll find the strongest signal. Bring the camera in. Let's have a look. And what we can see is, right away, the display is turned green. This is the signal bar right here. My peak response is right here, comes across the top. I'll pick it up and move it a little bit, one side to the other. So my very highest signal is right here. And ironically, my null response lines up in the same place. When you see a green display like that, it's quite a unique feature of the vLoc, of the Vivax line, because it's a color display, it's going to give us an indication of field distortion. So what it's telling me is right here we have a perfectly clean field. Peaks here, null's in exactly the same place, compass lines up and tells us that whatever we're tracing is going in that direction. We can see that clearly. And it turns blue to say, yep, it's a good clean field. So we're in peak with arrow mode, peak and null. It's about 3 foot 9 inches deep. We have 18.3 milliamps of current. Now, we start out with 25 milliamps of current, and we still have 18 left. We're locating this in 8.919 kilohertz. To prove out the depth measurement to see if it really is correct, I'm simply going to raise the receiver about a foot, and it went from 3 foot, let me just check that again. It went from 3 foot 9, I raised it up about a foot, now it says it's 4 foot 8. So we're getting a great depth measurement here, confirmation of depth readings. By raising it a foot, the depth measurement changed a foot. So at this point, I'm getting a great depth measurement. So I'm not interested. I'll locate back in through there in a few minutes. Let's walk out the other way. So we turn our back on our transmitter, and we're going to begin to locate this way. Now understand that as you walk away from a transmitter, the signal will naturally get weaker. The signal is bleeding into the ground, coming back to our ground stake. So we expect to see our signal getting weaker and weaker as we go. Perfectly natural. So now is when we begin to swing the receiver. So by simply moving the receiver back and forth, I'm listening for the loudest signal. You notice I'm listening for the signal. I'm not watching the display. I've watched lots of locators out locating this way, staring down the whole time, trying to find exactly the highest signal. My thought is just pick up the signal, follow it, listen for it, adjust your gain if you need to. So now I've got a good strong signal here. The 3 steps, as we began to talk about a minute ago, for locating are make signal, find signal, and then look at the signal. The 3rd step is stop and have a look and examine the field. What's the field look like? How strong is it? How much distortion is there? What general direction is it heading in? In other words, is this still the line I want to be on? So let's do that. Back there we had about 3 foot 9 inches of depth. Let's see what we got here. Here's my highest signal. My highest signal is right there, my peak. And my null response is in exactly the same place. It's pretty well right on the same money. I'm 3 foot 6 inches. I still have 18 milliamps of current from my transmitter. We had 18 and change back there. So we've got 3 foot 6 inches deep. If I raise it up about a foot, now it says it is 4 foot 6 inches. So we're getting great depth measurement here. Good current confirmation. This is a great locate. You notice the display has turned blue. Back there it was green, which meant there was no distortion whatsoever. What it's telling me here is there's just a little bit of distortion. A blue field, blue response means there's some distortion. Nothing to worry about though. So we'll pick it up and keep going. And as we continue to follow this line across the lawn, again, just following the sound. In fact, if that's a little bit too loud, we can turn the sensitivity down so all we hear is this. One little beep as we pass over top. Some knucklehead planted a shrub right on top of the power service. And so, as we continue to follow this line down, looks like I planted more than one shrub on top of the power service. Why, here's another one right here. Anyway, we keep going. So we're still just following this line. We can just listen for it. You can hear the signal is getting weaker, as we expect, because we're walking further and further from our transmitter. So let's stop and have a look at it here. Here's my high signal, right here, right there. There's the peak, right there. The little blue line touches the red bar. There's the peak. Now let's have a look at the null. The null arrow says move that way a little bit, so I do, and the null reverses itself right here. So here, in fact, if I just move it over a little bit, things have turned green. I have 35% signal here. Let's see. Yeah, this was my strongest signal right here, 35. So now we've got a clean field, lots of 4 foot 1, it's gone a little bit deeper, still have 20 milliamps of current, so we still have the same current we had when we left. We haven't really lost anything here. Nice clean field, undistorted. So let's keep going. So now we continue down towards the transformer. And again, as my current gets weaker as I travel away, I may have to turn my gain up a little bit, but it doesn't sound like I do. So it comes right to here. Let's have a look at it now. So here's my strong signal, right? My peak signal is right here. Let's find that right there. That's my strong signal. That's the peak. Now we'll compare that to the null response, which is right there. And this is exactly the same place within an inch or so. So peak and null line up beautifully between the 2 points. We've still got 18 milliamps of current, so we've lost almost no signal at 8 kilohertz. 3 foot 4 inches deep, it says. Let's raise it a foot and see what it says now. And now it says 4 foot 1. So we're within a couple of inches of precise depth measurement. So now this line just takes us right into the transformer at this point. Now, there's also a primary feeding from that transformer going right through this ditch under the cameraman here, Jeremy. So if I want to locate that, remember we've put signal on, we clipped on the meter base, so that allows a lot of signal to travel down this way. A lot of it's going to go to ground inside that transformer because that's what happens. There's a ground halo, a ground loop around the transformer. But some of it's going to go out on the primary and other secondaries. So let's have a look at that. I'm going to walk over in this direction and see what we pick up. So now, I'm not picking up signal out here, but if I turn my gain up a little bit, like so, now I am. So now I'm picking up a signal right here. Same 8 kilohertz signal that we put on up at the house. Here's my peak right here. Come on, have a look at this. Here's the peak response right here. I'll just put my foot on top of that. So the peak response is right there, right there. And now I'm going to look for the null response. Now, all the way from the house to the transformer, my peak and null lined up beautifully because the field was undistorted. In this case, my peak puts me right on top of the conductor. My compass tells me, yeah, I'm right on top of it. But my null response says, no, Dave, it's not here. It's over there somewhere. So let's follow that compass and see where it reverses itself. First thing I tell you is, because it's a short compass, it says we're still a long way from the null response. So let's pick it up and walk. And what you'll come to realize is there is no null response here. This arrow isn't going to reverse itself. And because of that, I know that whatever conductor this is, whatever it is, part of whatever network it is, the field is badly distorted. In fact, I had a sense of that even as I was doing this because the display is red. So because the display is red, it's telling us that right here we got a fair bit of distortion on this conductor, unlike the line that was feeding into the transformer. In this case, it says it's 4 feet deep, 4'2" actually. Let's raise it up about a foot. And now it says it is 4'4". Another good indicator that this isn't our target line, because we went from 4 foot, it should have said 5 feet, it only raised 2 inches. My current measurement here says about 5 milliamps of current. I had 20 milliamps on the feed line coming from the house in towards the transformer. So if someone said this line comes down here and then twists off in this direction, I would have to say I don't think so, because I started off with 25 milliamps all the way down here. I had 20 and then 18 milliamps, and now I have 5. The reason for that is my signal's going into that transformer. We lost a whole whack of it into ground, but I also suspect the signal's also going in the other direction out of the transformer. Remember, when you make a direct connection, current's just trying to get to ground to get back to the ground state. So let's take a look out in the middle of this street and see where this thing's going. So as we walk out here, we'll leave the gain the way it was set. Here's the transformer up here we fed into. As I pass the receiver, I believe there's a line coming across the street. As I pass this way, I look at my display and I see some signal right here. So now I've got signal right here. And again, here's my peak response right where my foot is, right here. There's the strongest signal right there. And my null response, again, is being pushed that way. And the reason for that is that field over there is pushing on this field, and when fields get together and start pushing each other, typically the null response gets pushed away. The peak hangs on, the null gets pushed away. So I'm going to walk over there and see if we can get a null response. And hey, I am getting a null response. Let's have a look at this. Here's the null response right here. So null is locking up here, but when I compare the peak to the null, here's the highest signal right here. So my peak is here and my null is here. Another indication this field is badly distorted. Now in this case, it says I have 5 foot 10 inches deep. If I raise it about a foot, it says 6 foot 10, and instead it says 7 foot. So it's actually giving us a pretty good depth measurement there, and about 5 milliamps of current, similar to what we had going across the driveway. So this line here just feeds across the street. It's a secondary service, leaving the transformer, going off to this neighbor across the street. Now we expect there's going to be primary feeding it in the other side of the transformer. So let's go in the ditch and have a look. Right off scale. Right off scale as far as signal, there's lots of it here. So as soon as any display goes off scale like this, the first thing you do is stop and knock the gain down like this. That gives you a mid-scale reading for comparison purposes, and then we start doing our trace. So here's the strongest signal right here, blue bar, red line right there. That puts us on top of our conductor, and I'll put my foot there, and the null arrow says, no, Dave, it's actually over here. So now we can see there's a little bit of distortion here. Here's our null response right here, and our peak response is actually about 6 inches further over to the side. Now that means we've got some distortion here. You'll also notice that the signal is jumping around here a little bit. I like to see a nice solid signal. So in this case, it says this line is 2 foot 5 inches deep, which I'm highly suspicious of. It says we have 7.5 milliamps of current. Let's raise this thing up. If it really is 2 foot 5 inches deep, it should say 3 foot 5 when I raise it. I raise it about a foot, and it says 3 foot 5. So it seems to be pretty shallow, actually, in spite of it. And there's a bit of distortion here, but it's not the end of the world. The display is turned blue. It's not red, it's blue. So we got some distortion, and my compass locks up and lines up blue that way. So this line happens to be fairly shallow right here. So we've clipped on the service. We had lots of signal coming out of the transformer. We lit up the primary coming and going, and another secondary going out. Let's go back now and clamp on the service instead of clipping on and see what effect that has. So a minute ago, we clipped on the meter base here to light this line up, and we could see that we had lots of signal on our service going out to the main, and also some coming in the primary in and out of the transformer, and the service going across the street. We also lit up this gas service off to our left side. We were able to minimize the bleed over onto the gas by moving our ground stake further towards the back and away from here. Now we're going to we're going to disconnect the clips and go to a signal clamp and see what effect that has. Now we're going to talk about using a signal clamp and maybe changing frequencies for clamping. So now here's our transmitter. This is an older transmitter, but they all work the same way. They all have a similar display. So in this case, I want to use my signal clamp and put signal on this service. My choices are to place the clamp around the incoming line, either down below or up above. It's easier to put it up above, so I'll just clamp around here. And now I'm launching signal. In fact, when you're using a clamp, you turn on the transmitter, it actually creates a force field or a field of signal inside the jaws of the clamp. So when you open it, it disturbs that, and then when you do that, now you've made the connection. Now the signal that's inside the clamp, it's leaving the clamp and traveling on the conductor traveling through this. Now you may know that when we're tracing service wire, power services, we're not tracing all three conductors, we're just tracing the neutral. Because for a clamp to work well, there has to be a ground behind the clamp, inside the building typically, and another ground at the far end, typically the transformer. So when you put a clamp around a hydrostack like this, because it's grounded behind you and ahead of you, signal leaves the jaws of the clamp and away she goes. If we put this around something that wasn't well grounded, the clamp simply doesn't work that well. Now, next thing is we're going to change from 8 kilohertz to 33K. Whether you do it in 8 or 33, it's a personal preference, but lots of people prefer 33 kilohertz for locating power using a signal clamp. We know that clamping, it works slightly better with higher frequencies. So now I'm going to push the F button, and now we're in 33K. So now we're locating it, now we're broadcasting at 33 kilohertz. The transmitter actually says, it just says I'm on level 1 output. It can't tell me how much signal it's launching onto the conductor because it doesn't know how much signal is actually leaving the jaws of the clamp and traveling on the conductor itself. The first time we're going to know how much current we have is as we begin our locate. Now remember a minute ago we clipped on the meter base and we lit up the power and the gas, which you didn't really want to do. Now by clamping around the stack itself and not clipping and not using a ground return point, let's see what difference that allows us on the locate. So again, we'll turn it in, we'll tune in 33 kilohertz. We'll step again 15 or 20 feet back. Always a good idea to start 15 or 20 feet back. And so I simply turn up my gain and I begin my locate. Here we go. I go right off scale, knock the gain down, and there she drops off. So here's my strongest signal. Come on in here. In fact, let me turn it back up. This is what it was when I first got here, quite high. I always like to see my signal a little bit lower than that, so I'm going to turn the gain down. I like between 25 and 35 or 40% signal. That way it gives me a nice tight little response. That's where the signal is right there. I can easily see it. So you see it's turned green, which means we have a nice undistorted field. A minute ago we had 20 milliamps or 25 milliamps output and still 20 milliamps here. We only have let's call that 5 milliamps here. So we have considerably less signal. The depth measurement's consistent. My peak and null still line up beautifully right there. There they are right there, peak and null. The compass turns blue. It's a nice, clean, undistorted field. So here we're getting less current to locate with, but let's see what effect this has on that gas service over on the far side. So a minute ago we had 20 milliamps here and about 1.5 milliamps over there. Let's go see what we got in that gas service now. So as I walk over where I know it was, I'm getting virtually no signal, virtually nothing. I'm going to turn my gain up and search a little bit harder. Yep, I am getting literally, nope, I'm getting nothing. Literally nothing. So we're not picking any signal up on the gas because we clamped on and used a higher frequency. Now, you might say that clipping gives you more signal, but if you have less signal, you get less signal to use a clamp, then clipping, now we light up a few of these other utilities. So now we're more certain of finding the actual line we want. You know, mistakes happen in line locating when someone comes out to begin to locate. They clip or clamp on to begin to locate, and they look around where they are and they see some red paint going in a certain direction. Someone's come out before them and done a locate. Maybe they were supposed to be locating gas, but they ran out of yellow paint and started using red paint. If you were a new locator and you clipped on that meter base and you saw red paint out here and walked out here and turned it on, you'd pick up signal on the gas service. You'd pick up signal from your transmitter on the gas service. If you didn't pay attention to peak or null or current measurement, you'd simply pick up noise or signal and trace this out and paint it red just like the last guy did. So the idea is we want to ask ourselves, does this make sense? So by clamping, we have less signal, but a cleaner signal giving us better response. Let's go back over and see what the response is as we follow down to the road. So here we are back on our line. Right off scale. Turn the gain down. And a minute ago, we had about 18 milliamps of current here. We got about 5 milliamps here, but that's still plenty of signal. Nice clean field, green display, 2.5 feet deep, raise it about a foot. It's now 3, and we got a bit of distortion, but it says 3 foot. We went from 2.5 foot to 3 foot. So this is a good example of a situation where someone says, man, I don't know what to make of this. I had a great depth measurement there. I could see 3'5", 4'5". Now I've got 2'6", raise it a foot, and it's got a 2'9". So what's the matter with this thing is the question. The answer is nothing's the matter with it. There's just a bit of distortion here. Something's causing this field to be a little bit too distorted to give us good depth measurement. We're still getting a great locate. That's what really matters. So we simply turn around and just continue on the same way. So when we continue to follow this line, the same path we did before, we're clamping now, not clipping. The line still travels right under this bush the way it did before. My signal here says, let's have a look here. It says 2'7", raise it about a foot, and now it says, yeah, 3 foot. We still have some distortion here. Let's keep going. We're still locating in the same place though. And now, we started off with about 5 milliamps back there. We're tracing down across the lawn, the same place we did before. Let's have a look at it here. So here's my high signal, right, let's find it. Here it is right here, the high signal right there. And now my peak is here. My null seems to be over there somewhere. Let's have a look. And the null response is over here. So there's the null response, and the peak response is still slightly over this side. So we're having more distortion here. That may be caused by the fact we're using 33K instead of 8K, because we know that the primary cable is over in that direction. And so it may be that at the higher frequency we're putting more signal on the primary, which is now pushing on this field. So in some cases, clamping works well, but in this case, we may be getting more. We had less interference, we had less distortion when we clipped on here using 8K. Let's continue on. The most important thing, of course, is where is the line, and we continue to get the same path, the same lie of the signal, still taking us the same place, but we're just going to experience potentially more distortion. So let's have a look at it now. Now our display is starting to turn red, which means we're getting a lot of distortion. Here's my peak response. Still going the right direction. My null says go way over there, Dave. And if I walk way over here, I see my null response here, which means that something over there is pushing on this field here. Again, possibly because we're using 33 kilohertz, higher frequencies light up other nearby utilities. Let's have a look at that. Let's compare this to what we know is the primary going across the driveway. A minute ago, we had signal here when we clipped on. I still have signal here. I'll turn my gain up a little bit to zero in on it. Here's my high signal right here, same place it was, right there. My null response on this one pushes me over in there. I'll put my foot here. My null response pushes me way over here. In fact, just like before, there is no null response here. That's caused by the fact that that is the stronger of the two signals. It's pushing more on this signal, and this signal is able to push on that one. Because the signal from our clamp is going into the transformer, and a lot of it's going to ground. We're losing a lot of it. So what little is left is coming out in this direction, but this field is weaker than the target field, so that field does more pushing and pulling. I think you get what we're getting at here. Clipping gives us more signal to work with, clamping gives us less signal, but maybe lights up fewer other foreign utilities. We could probably still, let's see if we can locate that service going across the street, 33K. And we're still getting signal here. So we're still able to locate this line. There's still enough signal, but we're down literally. We had 5 milliamps a minute ago. We're down to 1.5 milliamps here. So clamping gives us way less signal to work with. But nonetheless, there's still enough signal here to get a locate done. We can clearly locate this line going right across the street, just the way we did a minute ago.